Hey guys, welcome back to my channel. Today we're going to be live coding a simple data analysis tool using Python 3.7 with the help of Jupyter Notebook environment. So before we start coding, let's briefly talk about what exactly is Jupyter Notebook and why it's so useful. The textbook definition of Jupyter Notebook is that it is an open source web application that allows you to create and share documents that contain live code, equations, visualizations, and narrative text. Now, what does this mean exactly? Well, to illustrate a good example, let's say you're an intern at some company, and using your awesome Python skills, you generated some graphs that could be helpful for business insights, and you want to present this to your boss. Sure, you could just output these graphs as an image and then paste it onto some old boring PowerPoint, but there would be a lot of content and visualizations that would have been lost if you did so. Then you jump to the next conclusion, which is, okay, let's somehow figure out a way to have the whole script transferred to your colleagues. The only problem here, though, is that your colleagues, as well as your managers, might not always be proficient in Python or just development in general. So that they might not always be able to start up the project and all its dependencies. So then after a bit of thought, you come to a conclusion, which is either to make a web application or a desktop application to host your graphs, as well as the coding logic behind it and some interactive user interfaces. But this again is a problem because all this seems a bit too much just for a few graphs. And this is where Jupyter Notebook comes into play. Basically, it allows you to have some live code interactions and display options so that you can easily share and collaborate on the scripts you wrote and the awesome graphs which you have made. So without further ado, let's try to code a simple data analysis tool on Jupyter Notebook. For the purpose of the video, I've already created a skeleton notebook with all the packages installed, but if you guys would like to know how to set up a skeleton and fire up Jupyter in general, please let me know in the comment section below so I can make a video about that as well. Also for this tool, I've decided to use Google search trends to use as our sample data set. Google Trends basically just allows us to see how much or how often certain keywords or topics are being searched on Google over a specified period of time and across a specified region. Since I'm just generally interested in finance, I thought it would be interesting to see what patterns we can find for people Googling the keyword investing. So first, we want to begin by utilizing Jupyter Notebook's widgets, which will allow us to easily create as well as display simple user interfaces, which is also one of the reasons why a lot of people like Jupyter Notebooks in the first place. Is it allows you to easily set up and create user interfaces, granted not complex ones, but simple enough ones where you're able to interact with the graph and have a small and easy to use user interface. So for our purpose, we want to begin by using the file upload widget so that we can have some sort of way to upload files onto our data analysis tool, because if we have to keep editing the file path of the file each time in the code, it would be troublesome, and just all in all, it's always nice to have a little user interface to interact with. So to do so, let's begin by loading the file upload widget and saving it into the variable called upload. And you can access this widget by widgets.fileUpload, which takes in two parameters, one of which is accept, and the second is multiple. So in the accept parameter, we're able to input any file type that we would like the user to be able to upload. For example, you can put .xlsx, and if you also want to include .csv, you just separate the different file types with a comma, and anything you include in this string as a parameter, the user would be able to upload. For our purpose, we're going to be using a CSV file, but let's just leave it blank. This just means that it's able to accept any file type as an upload. So although we can specify CSV in this case, let's just leave it as blank for our purpose. And the second parameter is multiple. This just means if you want the user to be able to upload multiple files at once. For our purpose, we're going to be dealing with one file at a time, so I put it as false. Now, to see what we've just created, we can use the display function, which is as the name suggests, a function to display certain widgets and whatnot built into Jupyter Notebook to display the upload button we have just created. And if I hit Shift Enter to run this cell, we can see we've created this upload button. So now if we try clicking this, it should prompt us to be able to upload some sort of file. And then, for example, let's use this one, which we'll be using later on in the video. And let's see if we can upload this. As you can see, it was uploaded because the 0 changed to a 1. And so we have successfully implemented an upload widget. Another widget we have to always keep in mind is the output widget. And this will be useful later on when we want to control our outputs. So this is fairly simple to do. We could just load it once again from the widgets package and load output without any parameters. Now, although we've loaded up and displayed our file upload widget, we still haven't defined what to do with the file after it's been uploaded. Now, ideally, we want the process to be triggered automatically as soon as we've uploaded this to reduce any more manual intervention, for example, a clicking of a button, etc., etc. So we want to define a callback function that will be triggered once a certain event occurs. In this case, as soon as the file has been uploaded, we want this callback function which we will define to be triggered. So first, let's begin by defining what the file upload button will do after the file has been uploaded. So for our purposes, I'm going to call this function on upload, which takes in the event. I'm just going to use X here without. First, we want to begin by clearing any output which has been displayed previously, and this is why we sort of defined the output widget that we did initially. And this is helpful because if we want to upload one document after the other, instead of maintaining that interface, we want to refresh it and only display the information available to us in the new upload. So we can clear the output by calling out.clear output, and this should clear any output as soon as a new file has been uploaded. Now, the next thing we want to do is access this file and its contents. So to do that, we can access upload.value. To see what this value contains, let's first begin by printing it out. So we can do print on the upload.value so we can pick out exactly what information we need from this value. As you'll see now, once we print it, it actually contains a little more information that we actually need in this case. So we'll only pick out the information that we need and then use that information. So before we can print out the contents of upload.value, we first need to pass the onUpload callback function, which we've just defined, into an event listener. And in this case, we can do this by calling the upload.observe, observe, uh, and passing in the callback function on upload, which we've just created, and then specifying which event we want to listen to. Since .observe listens to, I think, all the events, we don't want it to be triggered multiple times just from one upload. We only want it to get triggered once there's a new value. So we want to specify value in this case. So when we try to run this cell again, and let's see what happens when we try to upload something. Oh, sorry, nothing happened because we also forgot to display the output as well. And let's try to rerun this cell. Upload, then cool. So we got this printed out now, and basically this is what we just printed out, which is the upload.value content. And as we can see here, we have a lot of things. Well, not necessarily a lot, it's just one field in the content is just the actual contents of the file. Hence you see this large block of text here. But essentially we are only concerned with the content of the file we've just uploaded. We don't necessarily care about the name of the file, the type, etc., since we won't be using it. We just want to fetch the contents from the upload.value. What we're first going to do is fetch the file name. And then use this file name to fetch the content, which is located inside the file name key and inside the content key. So this should now allow us to access the content each time. We don't need to print this again to view because we can already see the content here. We've just filtered out all the unnecessary key value pairs and just fetch the content itself. Now, to be able to interact with this tabular data better, we're going to use the power of pandas data frames and load it into a data frame. And to do this, we're going to first define our variable. You can call it whatever you like. I usually call my data frames df, short for data frames, and use pd, which is pandas .read csv. As we know, the file types we're going to be working with is a CSV file type. And then use io.bytes io object to load the content. Now, if we try to display the data frame, we should see the tabular data that we would normally see when we fire up a CSV file on Excel. So let's try to rerun this and upload something once again. Now, as you can see here, we've just loaded the data frame, and it's nicely displayed as a tabular data structure, much similar to how we would see this in an Excel. Now, for our purposes, um, we're not going to dive too deep into the different analysis tools, but we just want to, let's say we just want to print this out into a nice line graph so we could see the change over time of the interest in searching the keyword investing on Google. So to do this, we're going to use the Plotly package to plot a line graph. So I'm going to set up the graph, which I would call figure or fig in short, and use the px or the plotly.express package to fire up a line graph. And we're going to fetch the contents or the data of this line graph from the data frame we just created. And the x-axis for this is this week's column. So we're going to hit week here. And then for the y-axis, we're going to do the interest worldwide. Be sure, oh sorry, a typo here, but please make sure to have the strings here exactly as it is specified in the column, because essentially it's just referencing which column to take the data from. So we have this. Now let's see what exactly gets printed out once we run this. Of course, we need to display the figure again. Let's see if we rerun this and upload the file again. We can see here we have a really nice looking graph from the data we've just loaded. Now, as you can see here, although this looks great, it's not necessarily perfect just yet. We can go on and on about how to make this better, but at least a few points for now can make it slightly more readable. One thing is to include a title to know what exactly we're talking about. So let's just title this Search Results of Investing. This is the data for the past 5 years. Now let's see what happens if we try to display this. Great, now we have a title. However, I'd like to make it a little nicer by centering this. We can do that by calling the dot update and then passing in layout parameter. Now for a layout, it will be a simple dictionary which I would like to define here. You can just directly define it here, but once you start building more complex layouts, the dictionary becomes quite big, so it'll look messy if you just define it right when in the parameter. So I like to define it separately in a separate variable and then just pass in that variable as the argument to that parameter. So I'm just gonna center the title, and to do this, back, this should be a dictionary as well. To do this, I'm just going to define the x value, and this should be 0.1 to represent half or 50%. So now that we have that variable, we can pass in the layout variable here and then try to run this again and see if our graph is nicely centered. Awesome. So I'm feeling quite happy about this. There's always ways to make it better, but I'm feeling quite happy about this. So I think we can pretty much be finished with editing graph. But one other thing we need to do that I think would look nicer in terms of user interface is to get rid of this table, since it doesn't necessarily tell us any more information than we already have here on the table. I'm going to stop displaying this each time. So we displayed it here, so I'm gonna stop displaying it and just keep on displaying the figure. Now for final rerun. Awesome. Now we can see how the interest in the word investing has been steadily increasing and then spiking up in the beginning months of this year, which is quite interesting to see. Now, what if we wanted to upload other data sets, not necessarily just worldwide information, but region specific data? For example, the interest of the keyword investing in the United States, for example. In that case, we're going to have the column which indicates the y-axis with a different title. So to make this more dynamic, instead of hard coding this, we can just access the data frame's second column by doing df.columns and then choosing the second column. This way, no matter what that column indicates, we're always going to refer to the second column in our data field. So this is the worldwide data for interests in the word investing, but we could have another data set specific to the United States, and you can see here the data for the interest in the United States. Thank you for listening. Hope you guys enjoyed the content. Please make sure to like, comment, and subscribe. And please be on the lookout for more content like this. Thanks so much.